Let's see one of the protocol that we use at the application layer, which is DHCP. DHCP stands for Dynamic Host Configuration Protocol. So what it does is that, suppose you boot your computer or you start your computer, and when you start your computer, the computer doesn't know that what is the IP address of it. I mean, if you connect that to internet, then the computer doesn't know the IP address initially, right? Doesn't know its own IP address. Now there are two ways. Either I can assign, or as an administrator, as a network administrator, I can assign the IP address statically, which means I can manually type the IP address. So in Windows, there is, if you go to the control panel and if you go to the Wi-Fi settings or the network settings, then you will see one window where it asks for the DNS server, it asks for the IP address, it asks for the default gateway and these all details, right? So in Windows, you can do it using the control panel only. So it asks for the different details. So either I can type those details manually, and there is second option is that I can do it dynamically. So when I'm saying I can do it dynamically, here I do not need to type anything manually. It is done by the DHCP protocol. So first option is that I can give the static address, which means here I need to have the manual intervention. But it is definitely not desirable. Why? Because there are there are chances of errors. Suppose that you are typing every IP address manually, then it may happen that you are typing one IP address to one computer something and another IP address to some computer something, and these two IP addresses could be same, right? I mean, by mistake you may have typed two IP addresses which are same, so this will lead to IP conflict, which will be a problem. So it will not allow any of the computer to work in the internet. So anyway, like there are many problems with the manual intervention. Obviously this is not desirable, so we are looking for the dynamic IP addresses, and that is done by DHCP server. Now what it does, suppose that you are an ISP and you are given, let's suppose, some set of IP addresses. Let's suppose from this set, from let's suppose IP1 to you are given IP64, or maybe like there could be any number of addresses. I'm just assuming there are 64 addresses you are given. And whenever a computer connects to the internet in your organization, then what you do, you assign one of this IP address to the computer. So this is done by the DHCP. See here, why DHCP is important, because whenever you add a machine to network, then you need to assign some IP address. That's where DHCP is coming to the picture. And when computer requests an address, the administration would have manually configured the machine, but there are problems. Obviously it may lead to the mistakes. And second point is causes difficulty for both administrator as well as the neighbors on the networks. So anyway, like this manual intervention is not desirable, so that's why we are going with the DHCP, which solves the hassle of manually adding a machine to the network, right? So how does this work and what it provides? There are two things. So it not only provides the IP address. So IP address is one thing that it provides, but also it provides something else. I mean, some more details. One is DNS address, DNS server address. It also provides default gateway address and network mask and some other details maybe. But most important detail for us is this IP address, right? And maybe some other details. So there are some details that DHCP provides, right? So this is the screenshot that I have taken from Forogen, and if you read it carefully, then here also these some details are written, that it provides the network mask, which is prefix, the address of the router, which is default gateway, and the IP address of the name server, which is the DNS, and obviously the IP address, right? And the computer address, which is the IP address which we require at the first place. So not only the IP address, it also provides few other details. Now let's talk about the second question, that how does the DHCP work? It is very simple protocol. It works with the four features. So first, the client that doesn't have any IP address, it sends a request called DHCP discover. It says that I do not know what is my IP address. So here the source IP address will be just 000, right? And the destination IP address will be 255.255.255.255, which means it is saying that I want to broadcast this address and don't know my address. So this is the source IP address, this is the destination IP address, and this message is called DHCP discover. Now this message, since this message is a broadcast message, this message will be sent to every other host including the DHCP server, right? Broadcast message. Then once the DHCP server sees this message, it sends a DHCP offer. So it says that, see, I have one offer for you. Like, it's up to you whether you want to accept this offer or not. So why it is saying? Because there might be multiple DHCP servers, right? So every DHCP server will send some offer. It will say that, see, I have one offer for you. You can use this IP address for, let's suppose, 15 minutes. Some leash time will be there, or maybe 1 hour. You can use this IP address for 1 hour, something like that. This server is saying. Now based on the client, it will choose among all the offers. Let's suppose it has 5 offers. Based on the 5 DHCP servers, it is getting 5 offers. So it will send that offer. It will accept the offer of one of them. This is always a broadcast, because it has to be known to every other DHCP server. Suppose this client is accepting the offer of first DHCP server, but it broadcasts this DHCP request to every other to the network, because so that every other DHCP server get to know that, okay, their offer has been declined, only the first offer has been accepted. So this message will also broadcast, this message will also broadcast. Now this first DHCP server will say, okay, let me acknowledge you, let me just give you this IP address. So this is how it is done. This client is saying that I want my IP address, so that's why it is broadcasting. Now this DHCP server is sending some message to the client, like you can use this you can use this address, and then it is again broadcasting, so that again other DHCP server will get to know that, okay, this offer has been accepted, and then it will send the DHCP equivalent. Now these two messages that server is sending may be unicast, may be broadcast. So generally they are broadcast. If you talk about the frozen book, then they have said like these are the broadcast message. So all 4 are broadcast message based on the frozen book. But some author says, or some implementation says, that these messages that server is sending could be unicast also. Okay. So but anyway, these client messages are always broadcast. This message may be broadcast, may be unicast. Like if it is broadcast, then the intention behind is that this server is saying that, see, I am going to offer this much IP address for this much time for this client. If you have any other offer, so it is saying to other DHCP servers that if you have any other offer, then you can also send. So that's why this message may be broadcast or may be unicast. Similarly, this message also may be broadcast, may be unicast. So it depends on the DHCP server. If it wants other DHCP server to also let know that, see, my offer has been accepted and your offer has been declined. So basically that's why these server messages may be unicast or may be broadcast. Now see this diagram. So first message is the discover message, and this whole process is called DORA process, and these DORA, this acronym has been taken from this DORA. So first D is for discover. Now client is saying, hi, can you give me an IP address? Server is saying that I have this IP address, will you accept it? So this is an offer. Now client will say that based on the available offers, the client will say, yes, I accept this offer, kindly issue this IP to me and send the remaining configuration, which I told you, like default gateway, DNS server and all, right? And then server will say, okay, this is IP that has been assigned to you. And this whole process is called DORA process. I hope you got it.